Hello friends, welcome to our channel. Today we shall discuss on the second problem on pedal equations. So here we have the equation r is equal to e raised to theta into cot alpha. So by clearly observing this equation is of the form e to the power x. As we know that the differentiation of e to the power x is e to the power x itself. So therefore, first we shall differentiate the given entire equation with respect to theta. So differentiating the equation with respect to theta. So by differentiating differentiating with respect to theta means it will be dr upon d theta is equal to. So as we have discussed, the differentiation of e to the power x is e to the power x itself. Therefore differentiation. So differentiation with respect to theta. So differentiation of e raised to theta into cot alpha is nothing but e to the power theta into cot alpha. So just substitute. So differentiation with respect to theta means dr upon d theta is equal to differentiation of e raised to theta is e raised to theta into cot alpha. Then differentiation of theta is nothing but it is 1. So differentiation of theta with respect to theta is nothing but it is 1. So 1 into cot alpha. So 1 into cot alpha is nothing but it is just cot alpha. So therefore we have dr by d theta is equal to e raised to theta into cot alpha into cot alpha. By observing, we can observe that e raised to theta into cot alpha, e raised to theta into, we have r is equal to e raised to theta into cot alpha. So this is the given equation. So we can directly replace e raised to theta into cot alpha by r. Therefore dr upon d theta is equal to r into cot alpha. So now we have discussed the theorem, so we shall apply that theorem to obtain the pedal equations. 1 by p square is equal to 1 divided by r square plus 1 divided by r raised to 4 into dr upon d theta the whole square. So by using this polar equation, we can obtain the pedal equation. So therefore 1 divided by r square plus 1 divided by r raised to 4 into. So what is dr upon d theta? Dr upon d theta is nothing but it is r into cot alpha. So just substitute dr by d theta is equal to r into cot alpha. So it will be r into cot alpha whole square because we have square. So therefore 1 divided by r square plus 1 divided by r raised to 4 into, so r into cot alpha whole square. So it will be r square into cot square alpha. Therefore 1 by p square is equal to 1 divided by r square into, so 1 divided by r square into, here r square and 1 r square will cancel. So therefore it will be plus 1 plus r square into cot square alpha. So therefore 1 by p square is equal to 1 divided by r square. So here we have 1 by r square, here also we have 1 by r square. So just take 1 by r square common. So if you take 1 by r square common, so the remaining is 1 by r square. So 1 by r square is common, so it will be 1. So 1 plus remaining is cot square alpha. So 1 by p square is equal to 1 by r square. So 1 plus cot square alpha can be written as cosec square alpha. So cosec square alpha. So therefore it is 1 by p square is equal to 1 by r square into cosec square alpha. So this is in the form of 1 by p square. So just write it in the form of p square is equal to r square. So it will be cos into cos square alpha. So we have eliminated the fraction. So therefore it will be p square is equal to r square into 1 divided by cosec square alpha. So therefore it will be p square is equal to r square divided by cosec square alpha. Therefore just r square is equal to p square into cosec square alpha. So now we can observe that we have reduced the given equation in the form of p and r. So therefore the given equation is in the form p and r. So we have reduced it to pedal equation. So this is the required pedal equation. So from the given equation we have eliminated the theta and we have reduced the equation in the form of p and r. Therefore this is the required pedal equation. Thank you friends. Subscribe our channel for more updates.